Hello everyone, welcome back to the next lecture of Simulation of Business Systems and Allied Approach. I am Dr. Suman Samanto. So far we have discussed about how decision node can be used to divert the various customers depending upon the probabilistic number, depending upon chance. Second is that we have also discussed about how the assign node can be used for particular process and particular it can be used for making a decision whether the entity requires a particular process or not. Now and in the previous case also we have discussed the assign node, but the problem with the previous case is that it is not that much practical because we have in the process window we have assumed that all the processes require same kind of time, wherever in practicality it is not really the case. What happens is that you go to the bank and you try to do your work done, say for example money deposition and money withdrawal, or you are making you are going for demand draft or other options, but the time cannot be the same for all these processes. You have different time that you have to bear for other different kind of processes. So now in this case what we will discuss is that how we will make the processing time different for the different customers, whereas making the process done on the same window. So again we will draw this diagram of this arena model will be very much similar as the case 3. They are also will do the similar kind of things because we have only single window to serve all the processes. But what will be added is here is that in the assign node we will put another extra attribute that will specifically identify the process, and that will assign the processing time on the particular entity, and when in the server, I mean in the process window, when they reach to the process window, what they will do is that the window will take the processing time as assigned to the particular customer. So we will directly go to the arena simulation model, load the previous file, and then we will do the required checks, required changes in the previous simulation previous arena model file, and then we will show you that how it can be done and how the model can be run. So we will load the demo 3 that has been developed previously. You can see that the previous model is here. Now what will you do is that in the assign node we will put another attribute in each of the customer with the same attribute name. Say for example operation, and we put the value as normal 5,1. This basically signifies that we are defining one attribute named as operation, and the value of this attribute operation is normally distributed with 5 as a mean and 1 as a standard deviation. So what this signifies is that when it this particular entity reaches to this particular process all, the all will take the value of this attribute only, that will have to change this process characteristics that I will come later on. Similarly, for the assignment assign to node, we need to add the attribute whose name is operation, and its value is different from the first case, but this again distributes use normal distribution with, say for example 4 as a mean and 1 is standard deviation. And very similarly for the third case as well, we will add an attribute whose name is operation, and this value is normal with, say for example 7,1. 7 is the mean, 1 is the standard deviation. Now, when we assign these processing times in these three kind of customers, we have to make a change here. So, what we will do is that in the delay type we will use expression instead of using this distribution in the previous case. And what we will do here again is that we will put the name of the attribute that we have given to all these customers. The name of the attribute was operation. So, we will put operation as the point at this particular tab of expression. So, what this process now will do is that it will search for this expression operation and will take the value of operation as whatever defined in this assign mode. Say when this customer reaches to, I mean when this entity reaches to this particular process and it finds that operation is equals to normal distribution 5.1, very similar to this case as well. When this particular entity reaches to this process, the value of the operation will be changed to normally distributed 4.1. Rest of the things will remain very much same, because signature will be requiring similar kind of time as we assume, and other things are decision also will be required to be decided by using that previously we have defined as customer 2 equals to 1, and then after these services the exit things will be also remain the same. So, because we are not changing the resources as we have defined in the previous case, as we have identified in the previous case, because this will previously we have seen that we require 5 capacity resources in the window and 3 capacity resources in the manager. So, we are not basically changing it, because we have only used separate values, and we will try to find out whether these are basically working or not, whether we need to reduce resources, that also can be checked now. So, let us see how it again as I told you before that we need to find out the setup is okay or not. So, setup is fine because we have already loaded the previous case. So, the setup looks fine by saying this replication length is 240 and hours per day is 8 hours. So, we will run it again and we will check how the system works. So, you can see that number of total input is 106.9 and number of total entity out is 10677, that is pretty much same and pretty much close. So, there has, I mean with this attribute you can have a initial interpretation that whether you require a major change in the system or not. If there has a very huge difference in this value, then you can have an initial interpretation that there must have some issue on this particular process, and you need to find out very you need to go very close look into this queue and resource cases, and then you have to find out whether where the problem lies, and you need to make the corrective action. But since you can see that these two values are very close, then you can have an initial interpretation that you may not require that much close view, and there may not have that much issue with the system. So, as I said, when you see the waiting time, the average waiting time is 0.019, with a maximum value of 0.2 minutes. That is pretty much acceptable time, waiting time. Similarly, for the process sign also, they also the average waiting time is 0.099 and maximum waiting time is 0.98. That is also pretty much acceptable. And similarly, when you see the number of people waiting in the queue for the all window case, the average waiting number of people waiting is 0.86, whereas maximum value is 15. Signature case also, for the signature I mean process also, the average number of people that are waiting is 1.45. 1.48, and similarly the maximum value is 18. When you see the resource utilization, that also you can see the manager have an utilization value of 0.8230 and Windows have the value of 0.763 on it. These are pretty much acceptable I mean values that you can go with. So, the issue is that if we found that this value is very less, then we can think that there has some resource which is underutilized. So, even in this case also we can check it whether the resource is underutilized or not. Let us see, by reducing one resource for the all processes, and we let's find out whether the process was previously underutilized or not. So we have the total capacity of 5 windows for these all processes. So now let's reduce it to 4, and let's try to find out whether the process is basically underutilized when we use it as 4. So again we did the same thing, we just reduced the resource, number of resource, and then we run it again with the previously defined characteristics. So when we study the report, as I have said, the first impression is basically can be given whether the process is working fine or not by this number of entities that has been produced, and number of people that has been that is into the system, and the number of entities that got out from the system. So you can see the number of entities that went into the system is 10597, and number of entity that has been out from the system is 10582. So you can see these are very close. Again we can see that again we can interpret that the process doesn't get affected if we reduce the number of resources. So this also can be a case where the process is working fine, people are not understanding whether they want to reduce a resource or increase the resource, and once you get analysis and then you find out that there is one extra resource that can be reduced, and the process still can work fine, pretty much fine. So as you see in the queue also, even after the reduction of the resource in the all windows, you can see that average queue waiting time, average person's waiting time is 0.21, which is pretty much acceptable, with a maximum value of 0.990160. That is also very much acceptable waiting time considering the banking systems that we avail in our daily life. Similarly, when you see the queue length, the all queue length has an average value of 9.61 with a maximum value of 44. That may be once or twice in the entire run period. Similarly, for the signature queue is pretty much acceptable. When you see the resource utilization, then also you can see that though with the 4 windows we have around 0.93% 0.93 resource utilization and 0.82 as the manager, as this is very much similar as previous, but the Windows resource utilization has been increased from 0.73 to 0.93, but still you can say that this is pretty much okay with the system, because there has some idle time for the window resources. So that's how you can do a managerial interpretation of the results, and you can find out whether we want to add a resource or we want to remove a resource, or this kind of stuff. So when you see this stuff, then you can GUI after the run, then you can see that here also you can find that there are only 12 customers that has been not served after the end of the run. That is also this since we have used various probabilistic distributions, this kind of numbers may vary in the real life situation. So 12 is pretty much acceptable number of people that can be we go with without making any change. So that is how you do use these assign nodes to assign various processing times, and that is how you can change the process to get accompanied with these assign nodes, and find out the how different customers can be processed at different timetables. So this is the case 4, and we will discuss another case after that, which will be discussing about this two more nodes, that is one batch and separate. We will discuss after saving this file, we will discuss that, and then we will develop the simulation model for that. We will run that in the arena. Let us come to the final case, in which we assume that the customers entered to the bank as a batches. Though it is not a very much normal situation in the bank. In the bank, people used to come and they enter into the bank directly. But for the in order to show you how batch and separate node operates, so node can be operated in the arena, we have made this assumption that one people cannot enter into the bank directly. There has some number of people. Once a number of people gets gathered, then they will enter to the system. Enter to the bank. So similar to the previous case, we will have 3 create nodes here. We will discuss it by pictorial. Then we will discuss it in the process flow. Then it may be much clearer to you. So Again C1 is stands for money withdrawal or money deposit, C2 stands for demand draft making, and C3 stands for other operations. So, previously what happens is that this C1, C2 and C3 directly enters the bank and go to the process, but in this case they do not directly enter to the bank. They first need to sit in a, say for example, in a waiting room, and until and unless a number of person gathered, they cannot enter the bank. Okay. So, basically this batch particular node is used in process industries where you need to make some, say for example, when you need to make assemblies and other things. Say for example, there are 3 separate parts that are processed from different there are several parts that are processed from different process flows, and then they need to be joined. So, under this kind of scenario we use this batch node. There are other industrial implementation of this batch node is that, say for example, you need to transfer material from one particular position to the another particular position. So, under this case maybe you may not be transferring the materials, I mean materials or parts individually. So, under that scenario also you need to wait until a number of parts came to a particular point, and then you collect those number of parts. Say for example 20 say for example one person can take a a bag, and they can transfer 20 parts together to the next particular location. So, until and unless 20 parts comes, that person cannot transfer their material to the next person. So, this kind of scenarios are scenarios will be requiring this batching node in the ARENA simulation to be utilized. So, coming back to our particular case. So, again we will try to draw this figure first, then they will draw this process flow first, and then go to the ARENA. So, we have made placed a batch here which will collect number of people, I mean the number gathered here will put it reaches to the bank. Say for example, reaching to the bank requires another 5 minutes of time. So, we will put it as a delay, and then once they return to the bank, the customers basically moves to the, once customer reaches to the bank, the customer basically needs to be separated, because otherwise if it is not separated, then I mean once you have made a batching of the customer, then the ARENA, what ARENA thinks is that there is only one customer. So, before entering the batch, entering the bank, you need to separate this batching, otherwise all these whatever number you have decided as a to go as a batch, that number will be joined together and make only one entity. So, before entering to the before reaching to the process, you need to separate them so that the ARENA can realize that they are basically separate entities. So, after that you put the process, and then whatever the process is, then again that decision node, that whether the customer is from customer 2, or I mean whether the customer wants to make a draft or not. If he is making the draft, then you may be adding this signature process. If not making the draft, then you maybe put them into the exit. Here also you can put them exit. Before reaching the batch, we need to assign, put the assign node as well, just like the similar case, just like the previous case. So, this is how you will batch, and now batch and separate nodes. Now, we will use ARENA simulation software to demonstrate this thing, and that will be much clearer to you when you use the ARENA simulation software. So, we will put another new file, we will develop another new file very similar to previous one. We will make 3 separate create nodes. we'll give name to the separate create nodes as differently. Say for example, the name of this create node was customer deposition and withdraw, random exponential with %1 per 2 minutes. Similarly here also customer draft. So also I can put into the minutes. 3 minutes. 3 minutes per one customer arrives after in each 3 minutes. Similarly for the third create node, we can give the name as customer other. Here you can say in every 5 minutes one customer arrives. So similar to the previous case, we will put assign node in front of each create node. Just like the last case, we will put two attributes. One is for specifically detecting it, whether it belongs to customer 2 and add one process to it, and the second is the second attribute will specifically define its processing time. There is normal 5, 1 is again the normal the processing time for this particular customer, normally distributed with the mean 5 minute and standard deviation 1 minute, to repeat the thing again. So again for the second customer, we will need to add two attributes. Attribute 1, which is basically customer 2, whose value will be 1, and second is attribute 2, which is basically the processing time. The third case will do the same thing. Customer 3 value is 1, and one more to add attribute, it is banking, put the value as so as I said previously, we will add a batch here, and we will say that in this case, until and unless a number of people does not reach to a particular place, they cannot enter into the system. So if you see the batch, there has particular bottlenecks, there is a particular place where it says the type of the batch. So there are two kind of types, one is permanent, one is temporary. Now the permanent batching is used normally where assembly operation is done, because once assembly operation has been made, then you do not require to break the batch, because it became one particular 3 parts joined together and they make one particular product. But for the case where you need to transfer the parts to another places, so when you need to transfer the parts to another place, if you make the batch as permanent, then what will happen is that you cannot separate the parts again. So when you need only this transfer kind of operations, then you need to put this as a under the category temporary batch. So and below this there has another particular place which says batch size. So you need to define the number of batch size. Batch size is that the number of entity if the number of entity is lesser than this batch size, the batch does not allow the entity to pass through this. So, say for example, for this particular case we will take the batch size as 20, and the rule is there is a set of rule that you need to define whether you want to seek for a particular entity or you want to seek for any entity. So, if you click there, you can find that there is two things. One is any entity and by attribute. If you put the by attribute case, then you need to specifically define what kind of attribute you want to know. But here we do not want to put that. We only want to keep it as a any entity. So, once we do that, then again as we said we need the delay. I mean, that is basically, say for example, the people require to move from from a particular place where they join together. When 20 people come together and they walk together to the bank gate and they enter into the bank gate. So, we consider this as a transfer delay or a transport delay, transport underscore delay. So, this is basically a delay, not a process. So, if we keep it as a delay, then we will keep it as a constant value of say 5 minutes. When we say that 20 people after gathering together, they need to walk for 5 minutes to reach to the bank. So, that is what it basically signifies. So, once they reach to the bank, we need to again separate them, otherwise the ARENA simulation will take these 20 entities together and they treat them as a one entity. So, we will put this separate node here. Now, when you click the separate node, you can find that there is in the type there is two kind of properties. One is duplicate original, split existing batch. Since we haven't used the permanent batch, we will use this type as split existing batch. Now, the members attributes column, you can see that there is 3 options, whether retain original value, entity value, or take all representative value, or take specific representative value. So, what the thing is that if you click any of these, then you need to change the attribute values and other things, but we want to retain the attribute values because the entity values that we have been already defined in the assignment node, because once we go to the process case, once we go to the processing window, we need these values to get them processed. So, we will keep this particular attribute as retain original entity values. Now, similar to the previous case, again we will add the process of banking, and say for example, as we given the name as all. So, we will put the name as, keep the name as all, and we will make the name of the process as window, and similar to the previous case, we will add expression here, it is minute, and the expression name is banking. So, before giving the name, you can also check that what name you have given, otherwise it can create an error. So, as you can see, we have given the attribute name as banking, which basically defines the processing time of these customers. So, we will put expression name as banking. Again, we will put the decision node in order to identify which of the customers belong to the group which want to make a draft. So, we will again use two-way by condition with the attribute name as customer 2 equals to 1. Then we would use two different disposal node. We will give the name as exit 1 and exit 2. Now, we will join these nodes again. I need to put in one more process. That is basically signature, and its name is resource name is manager. The time is normally distributed as into. So again, to brief the system, you can see there are basically three different create nodes, separate create nodes that create separate kind of customers. That is, we defined that customer arrival time for different customers at different. Now, each customer for each customer we have assigned two different kinds of attributes. One attribute will separately select them which kind of customer it is, and the second attribute value will define this processing time in the banking window. So then what we do is that we define that until and unless 20% reaches to a particular place, they cannot enter to they cannot go to the bank, because there is a transportation system which allows 20 people to reach to the particular bank. So similarly, the transportation system takes 5 constant minutes time to for the batch of 20 people to reach to the customer window, to the banking window. So once the customer reaches to the banking window starts making the operation. Banking window checks for this expression banking and takes the value whatever the banking particular attribute banking carries or assigned in the assignment block. So once this operation has been banking operation is done, then the arena tries to decide whether the customer belongs to the customer 2 attribute, that is whether the customer want to make a draft or not. If the customer want to make a draft, then the decide block directs it to the signature process, and the signature is done by the manager, and the particular customer exits. And if the customer is not seeking for a draft, so the customer directly leaves the system. So again, like previous one, here also we add the attribute for the particular windows. Here only we have add the resource in the particular window. There is only one capacity in the resource window, so we will increase it to 3 at least. Because we at least have 3 3 different kind of processes, so we add the capacity to at least 3. Now we will run this again and we will try to find out. So now we will run this model and we will check out what are the problems in the system. So you can see the run has started. It will go till 240 hours and then it automatically stop and go for. See, again, as you can see, as I have discussed previously, when you see there is a discrepancy in number of entity that enter into the system and number of entity that got out from the system, then you will find that they definitely have some issue in the system. So as you can see that there has 15,430 number of entities that has been entered into the system, and there is 6,666 number of entities that has been got out from the system. So we need to check the queue and resource, that whichever process is basically overutilized and they require to be processed to be added. Like the previous cases, as you can see that all queue have an average waiting time as 53, and with maximum waiting time is 104. Very similarly, the signature queue also have an average average waiting time as 55.47 minutes, and maximum waiting time is 110 minutes. Similarly, number of persons waiting in the queue for the average for the all queue there is around 3214 number of people that are waiting in the queue with a maximum value of 6505 number of people. Similarly, for the signature queue also we have 613 number of people waiting in the queue on an average with a maximum value of 1243 number of people waiting in the average. As we have used the batch node, we can see that there has another queue that has been added, that is batch 1 queue. So, the batch 1 queue also have some average waiting time and the maximum value. We are not concerned about this thing because we have to bear with it, because we have made the assumption that until and unless the batch size is 20, we cannot get into the system. But it is not like this cannot be analyzed. We have to analyze this part also to identify whether the batch size is optimal or not, because in some cases what happens is that you increase the batch size insignificantly, and that causing a problem in the system. Because say for example, instead of making the batch size as 20, if we end up developing a batch size of 100, and then what happens is that there are more number of people who are waiting to get batched, and ultimately the process is affecting. So, this also have to be taken care of. So, first of all we need to take care these two particular processes, then we will discuss how the batch size change of batch size can impact on the process. So, as you can see, the manager and the window or Windows utilization is almost 1. So, we definitely, and there are two issues, one is 3 issues basically. There are number of input and number of output is significantly different. Second is queue length for these two processes are very high, and queue length for these two processes is very high. Waiting time is also very high. Similarly, the resource is also, the resource utilization is also nearer to 1. So, we are pretty much definite that we need to add extra resources to these particular two processes. So, very similar to previous cases, what we will do is that we add capacity in the resource block. We will go to the resource block, we increase the capacity from 3 to 4. Here also we increase the capacity from 3 to 2 for the manager. So, by adding these capacities, we will again run the model and we will find out how this is basically working. So, when we check the entity, we can find that again we have a large number of discrepancy in a number of input and number of output. That is, number of input is around 15,500, number of output is around 11,031. So, we will check to the queue. Again we see that all system, all window queue and the signature manager queue are queue having larger waiting times, and similarly number of waiting is very high for the all window queue, and for the signature queue also have been it is significantly high. For the resource case as well, you can see both are still having nearer to the nearer to both the process still have utilization value nearer to 1. So, we will add one more resource to each of this block, each of this process, so that we can reach the optimal value, and then we can change batch length, and we will show you how this batch length affects the process. Now, you can see that number of entity the entity input is 15,394, number of entity output is 14,308. So, similarly the queue length has been significantly reduced, but the all queue is still very high. All queue minimum waiting time is around 7.5 minutes, maximum waiting time is 15 minutes. However, still the all queue looks very high. As you can see, the all queue have an average utilization is 0.99. So, this is still pretty high. So, we will add another resource here. then we will check it again how it is behaving. So, now you can see again it has been improved, the input and output ratio has been improved from the previous case. Now, we will check the queue size and queue length. So, now the queue size and queue length has been improved for the all queue, but for the signature queue it has been again increased, because for the window, for the process resource window, you can see that the average utilization has been reduced, but for the manager it is still 0.1, I mean near about 0.1. So, again we will add this resource, I mean increase the resource to 4, and then we will run it again. Now, you can see that number of entity out is pretty much, now you can see that there is very less difference between the number of entities input and number of entity output. So, you can see the queue length, if you see the queue length, the queue length has been, I mean queue characteristics, you can see the queue waiting time has been significantly reduced for all the cases. Similarly, the queue length has also been reduced for the significantly for the all the two processes. So, now if you see the utilization factor, then also you can see that the utilization factor has also been reduced. So, you can say that now the system is in steady state condition with the resource window having 6 capacity and manager having 4 capacity. Now, we will do a little bit of change in the batch size, and I will show you how this batch size can affect on the process. So, previously we have used 20 as the batch size, now we increase say for example 200 as the batch size. Now, you can see that how this will impact on the output. So, previously we are getting around near about same kind of entities enter into the system, near about same number of entities were going out of the system. Now, we have increased the batch size to 200. Now, let us see how the system affects by this. You see when we increase it to 200, still it is not affected. So, not much affected, I mean you can say 200 number less entity got output from the system. So, you can say it is not that much affected. So, what we do is that we increase it abruptly to some very large value, say for example say until it reaches 20,000, 2,000 it cannot go out. Now, you can see that now you can see number in and number out has been significantly changed because of the abruptly increase in the batch size. We have increased the batch size from 2 to 20 to 2000. So, this problem has happened. So, what happened is that in the queue characteristics, I mean in the queue characteristic, what happened is that the waiting time for the signature queue and all queue has been remains almost similar, but the batch queue has been waiting time in the batch queue has been increased. Similarly, waiting number of people waiting in the, I mean number of customers waiting in the batch queue also has been increased from the previous one. Previously it was very much negligible with around 7-8 people are waiting in the queue. Now it has been increased to 961 and 2000, because this is basically we are allowing 2000 people together going out. So in this way we can see that we have to find out we can select a batch size which basically optimizes this particular process, or we can find out how this batch size can impact on the process as well. So that's how we can use various nodes in the simulation software to describe various different kinds of situations. And we have used here very simple models so that you can work them out in your system itself by installing the student version of the Arena simulation software, because the licensed versions cannot be available everywhere, and thus you cannot get an hands-on with the licensed version. So we made these models very simple, and I also recommend you that when you do study these videos, you please install then a student version of the Arena on your system, and you develop those models along with the videos and run them on your system, so that you can get a good idea about how these nodes can be used. So that's all from my side, and I will wish you all the best for your for the course.